Hi, my name is Brian Sizdek. I'm a psychologist and the product manager at Stolting. We're a publisher of psychological assessments, including the Stroop color and word test. I'm here to talk with you about the Stroop color and word test normative update, what you need to know to use, administer, and interpret the test. So, as you may be aware, the Stroop is a classic efficient test of executive functions, particularly inhibition and processing speed. The new edition of the test was developed to, number one, retain the essential features of the current version, which will enable people to use it across versions if they're using it for longitudinal research. We'd like to update the normative tables to reflect current adult U.S. demographics and use some updated analytic techniques to examine the psychometric properties of the test. There's a need to clarify some administration, scoring, and interpretation procedures, and update the literature review with current research, and also to develop a scoring application that can be used that utilizes features like dynamic interpretation and reporting. So the Stroop, you may be aware, is divided into three main tasks that are done. There's a word task, which just consists of just words in a black ink. People will go through and read those as quickly as they can, and the score is the number read correctly in 45 seconds. There's a color section. Again, the person names the correct colors, and the total number is the score for color. And then the color word is an incongruent condition where the color and word is mixed. This is a test to test if a person can block out that competing stimuli, in this case, the color, in this case, the word, and then just name the color. And then interference is an additional score, which is a calculation that's done by taking that color and word score and subtracting the predicted color word score, which is generated by a person's color and word congruent performance. So it's a comparison against what a person's capable of, internal comparison. We'll talk more about how that affects interpretation. For this update, the methods and materials that are used, first of all, gathered user feedback and user data about current trends, about who's using the test. We examined those for themes and wanted to integrate to be usable with the current administration. For the literature review, we looked at literature that's been published since the last publication of the Stroop and focused especially on factors that would affect administration. So looked at literature, research people that are finding things that would be helpful to know if you're administering the test, and then seeing its application in new settings since the last time it was updated. With the standardization, the previous version of the Stroop test was used with the same administration procedures to a nationally representative sample of 373 individuals ages 15 to 88. We also looked at the test retest, so gave some people the test and gave retest up to 2 months later, and then looked at concurrent measures, the Woodcock-Johnson letter word and word attack, nonverbal Stroop card sorting test, and color trails making test. These measures were chosen as based on theory. They're alleged to evaluate some of the same areas that the Stroop color and word test does. For standardization and development, participants were roughly stratified to match current U.S. demographic criteria. And then the different levels for each of these demographic variables was evaluated to see if there's any differences between the different groups. None of these stratification variables were important outside of age and education. Once those were accounted for, other differences disappeared. So those age and education was incorporated into the models. And just for some score description, these are the average scores of all the entire sample. You can see that the color word and color word raw scores all appear to have a approximately normal distribution, as verified by examining the residuals in the models, centered around a score that represented the number correct in 45 seconds. Interference was roughly centered around 0 because, again, that's subtraction of what's predicted for a person to have for color word subtracted from what they actually did score for color word. So we'd expect that that prediction, those residuals, would be approximately 0, which they approximately are. Models were constructed to predict the scores. There was allowance for nonlinearity, and we can see that nonlinearity, a nonlinear model best represented color predictions. And so we can see as we move across in all the models, move across age, scores tend to decrease, going up to age 88 in this sample. And then also there was some different scores, significantly different scores based on education level. Roughly as education increased, score level also increased. So those were for color word and color word scores. Model. These are the plots that represent the models, the regression models that were constructed. And from these, we were able to construct prediction tables. So for each scale, there's a separate education level. You consult that table based on the person's education level and then look at their age. And for this edition of the Stroop, the age groups were not at necessarily regular intervals. So it could be a certain age band of like 3 years, and then the next age band could be like 4 years. And you'll consult that to find the appropriate predicted score. For interference, interference also had a significant decrease over time in predicted scores based on a person's age. We can't use this in paper-based tables because we can't have a separate table for like each age, because interference is a function of color and word. We wanted to also account for age somewhat, but without having a separate table for each year of age. So a segmented model was constructed and found to be significant. And it was found that the best age break was represented by age 68. So under 68 and then above 68, including 68, were two different regression equations. And from that, we constructed interference prediction tables, ones that were above or equal to or below age 68, and then consult that table based on the person's age, and then using their color and word scores, generate a predicted score. From all of those residuals then correspond to different t-scores. We can also look at the structure of the Stroop, and using some principal components analysis, we looked at the way that the scales correlated. We can see that basically the 4 different scales tended to form 2 dimensions, one which we can call processing speed, which consists of color and word, which are just raw measures of quick, efficient rote processing. And then another dimension that can be called the Stroop dimension, which is the color word, and interference, which is ability to inhibit that competing stimulation and focus on the needed stimuli. Looking at the internal reliability of the test using these factors, we can see that using alpha, Crown Box alpha, with the 2 factors combined, we had roughly a 0.7 alpha level. Looking at omega, which is a measure of composite reliability, there was a higher measure that's 0.89. Generally, composite reliability is considered a more accurate level of representation of internal consistency because it allows for these factors that are not necessarily perfectly correlated to separate as such. Looking at retest reliability, we can see 0.5 up to 0.9 values for interclass correlation coefficient and concordance correlation. The lowest ones were for interference, and then higher for the other measures. To look at concurrent validity, I looked at the correlation of Stroop scales with those other measures that I mentioned were used for concurrent validation. And we can see significant levels of correlation with other tests, and in particular, some of the scales mapped more closely with others. In the manual, this is described further, looking at discriminant validity and assigning some of these different scales to a particular dimension, and looking at how they group together. For the literature review, we found that there's an increased use of the Stroop internationally, seeing some basically consistent findings, some discrepancies, some differences in some different demographic factors about different scores. We see an increased use of the Stroop in clinical trials. For example, one area of particular use in Huntington's disease, the Stroop's been incorporated into a standardized battery. Other literature, we see that the Stroop's used as like a stimuli in MRI studies and newer technology since the last edition of the Stroop. For administration and scoring update, as I said, we wanted to clarify the administration directions. So it's clearer now of how to administer one form for the examiner, one for the examinee, and the examiner is actually only recording in his or her own booklet. So that's the one that's used for the examinee. The other is basically a stimulus card for the examinee. There's also a new administration protocol which can be used as a script, either to ensure standardized administration or like in a clinical trial setting for people to administer in a standardized way. There's a new qualification check on the record form to ensure that that you'll get a valid result, that the person can accurately read the stimuli. There's also a new plot section on the summary form to present results in an informative way, and that's also on the Stroop application. And so we can see that comparing using the new models of the Stroop, we're seeing more closer performance to what's predicted. So essentially, we're seeing lower residuals. So it seems that the Stroop is going to be a little bit. The new algorithms are closer to what we'd expect a person's performance to be. So another area that we wanted to clarify was interpretation, and we wanted to clarify the meaning of all the scales and the interpretation strategies. Especially wanted to emphasize to use all the scales. You know, a lot of people think the Stroop, and they think interference is the main measure of the Stroop, and it is the main measure, but it should be interpreted in light of the other scales also. And especially, I think there's been some confusion about the difference between color word score and interference score. So color words in normative comparison, you're seeing how a person does on color word compared to all others when you're looking at the color word t-score. When you look at the interference t-score, you're looking at how that it's an ipsative comparison. So you're looking at that person's performance compared to him or herself based on their performance on the other scales and what they seem to be capable of. Now, that all those should be interpreted in light of each other, and those they are all important comparisons but have some different meaning. So as an example to illustrate, this plot is from the HDRS, the Unified Huntington's Disease scale initial validation, where they used the Stroop and generated some normative data. So I just plotted the normative data, converted all those to t-scores using the Stroop application. And we can see if we just focused on the interference score, that the average score for people with Huntington's disease in this study was pretty much exactly average, really close to 50. So if we were just saying, what's the Stroop effect for this person, for these people, we'd say, well, there doesn't seem to be much use for giving the Stroop. They seem to be all average. There doesn't seem to be much difference. But if we look at the other scales, we can see those are significant to more strongly significantly below average. And that's because their color word performance is below average compared to the general population. But also the color and word performance is below average compared to the general population. So they're having difficulties with rote processing speed. They're also having difficulties with processing information in a more complicated setting when there's competing stimuli. But that's not showing up that's not necessarily below average compared to, it's not a deficit compared to the ability to process information as represented by word and color. So when we subtract the color word the predicted color word score from the color word score. It's coming out average because they're doing below average across the board. So in conclusion, this is discussed more thoroughly in the manual, but just based on what I reviewed here, there was a Stroop normative update to focus was to clarify all the procedures of administration, scoring, and interpretation, to update the literature review. In standardization, we wanted to use a nationally representative updated sample. We found that age and education were the only significant stratification variables, so the Stroop seems to be performing fairly across different groups. We generated models to predict scores from which residuals and t-scores can be obtained. And we want to update tables grouped by education and age group. Then also the interference score is now segmented to those below and those equal to or above age 68. The factor structure, the dimensions of the Stroop seem to separate into two dimensions. There's strong composite reliability. And in terms of test-retest reliability, we saw moderate to strong test-retests for different scales. And then it seemed to correlate well with other measures that seem to assess the same areas of the Stroop. So please contact me if you have any questions about this test, using it, getting more information. I'm one of the co-authors of the test, and would be happy to provide some help helping you use the test, or if you have any questions about potentially using it as well. Thanks. Have a great day.